Lesson 6.3 is where we're headed today. Officially it says binomial radical expressions. I'm going to go with it's adding and subtracting radical expressions. So number one thing we have to figure out before we proceed is what has to be true of radicals to add and subtract them. Okay, and you'll notice right up there, it says radicals must be, and then it says, quote, like terms in order to add and subtract the coefficients. So kind of like in order to add and subtract x's. You could add and subtract an x squared with an x squared, right? Like 3x squared plus 5x squared. You can do that and get 8x squared. You can add and subtract 2x and 4x and get 6x. But we can't add or subtract, say, 2x and 5x squared, can't we? Okay, they have to have the same powers. They have to have the same pieces. And that's the same thing here. So they have to be like radicals, meaning like multiplying and dividing. First of all, they have to have the same index or the same root. So you can only add square roots with square roots, cube roots with cube roots, so on and so forth. But the other thing is, when multiplying, it didn't matter what was under the radical. Now it matters. Those radicals, in order to add and subtract, have to be identical. Because then what you're adding and subtracting is the number or the coefficient out front. And that's what we're going to practice in this example 1 that will kind of lead us in and get started here. Okay, so let's look at example 1. Simplify each radical expression. 3 square root of 5x minus 2 square root of 5x. Guesses? Square root of 5x. Agree? Disagree? Agreed? Are these like radicals? Yes, they're both square root of 5x, aren't they? So what is it that we are subtracting? The coefficients of 3 minus 2. And what is 3 minus 2? 1. But she didn't say 1 square root of 5x. Okay. If your answer is 1x, do you have to write the 1? No. So same thing here. If your answer is 1 square root of 5x, do you have to write the 1? No. So now, the idea that I can put up here is basically what she did, or what we're going to do, is 3 minus 2 times the square root of 5x. In other words, if you have to show work or something, it's doing 3 minus 2 square root of 5x. But we know 3 minus 2 is 1 square root of 5x. I personally would not count 1 square root of 5x wrong. Math Excel, on the other hand, I can't speak for Math Excel. I have zero control over what they count right and wrong. So, realize a coefficient of 1 you do not need, and so it is just square root of 5x. Easy enough? Okay. B. 6x squared square root of 7 plus 4x square root of 5. What are your thoughts? Can't do it? Why not? Okay. In order to be able to add and subtract, folks, it's not just the fact that they both have to be square roots, they have to be square root of the same number. 5 and 7 are not the same number. So, for the benefit of what we're going to do right here, I'm going to write cannot be combined. My reasoning that they cannot be combined, I'm going to give you a vocabulary word here. The radicands are different. What do I mean by radicands? That's going to be the number or term under the square root. Okay, so in this case, basically what I'm saying is that the 5 and 7 are different. But if you want the official lingo, it's the radicands are different. example C. 12 cube root of 7xy minus 8 cube root of 7xy. Thoughts? You think they can? Okay. They're both cube root of 7xy, yes? So when I subtract these, what do I get? 12 minus 8 is 4, so my answer is going to be written as 4 times the cube root of 7xy. Okay, easy stuff right here, so nothing too crazy. Let's go look at the second row. Let me know if you have questions as we go. D, 7 cube root of 5 minus 4 square root of 5. What? You don't think they can be combined? Why not? Okay, the official word is that the indexes are different. They're different roots. So we've got a 3, and we've got an invisible 2. And we've got a 3 and an invisible 2. They're different indexes. So again, I'm going to say cannot be combined. And in case you need to give a reason, it's because this time the indexes are different. They're not the same type of root, is what I'm saying. Okay. 3x square root of xy plus 4x square root of xy is what, class? That's a very small class for a very full classroom. But I agree. Square root of xy and square root of xy are the same. 3x and 4x is 7x. 7x square root of xy. And F. 17 times the fifth root of 3x squared minus 15 times the fifth root of 3x squared. It's a mouthful, but it's easy, right? What do we get? Okay. 17 minus 15 is 2. The radical, the index, everything is the same, so it's times the fifth root of 3x squared. Questions there? Okay, let's look at this word problem. The following is a picture of a stained glass window made up of square pieces and portions of square pieces of the side. If the side of each square measures 5 inches, find the perimeter of the window. What do we mean perimeter? The outside, right? All the outside edges added up. So keep in mind, the following is a picture of a stained glass window. So we're wanting the perimeter of this whole piece, yes? And what are we told? Each side of each square measures 5 inches. And picture may not be precisely exact, but these are squares, right? Realize that these are all half of squares. Okay, some of them are not drawn precisely, but so if each side of each square is 5, that means here's a 5, here's a 5, this is 5, this is 5, so on and so forth, right? You can draw in lots of 5s there. I'm just trying to give you guys some 5s to go by. What do I have to know to be able to figure out the perimeter of this window? Okay, the distance of the halfway line. Ooh, I like that word. Hypotenuse. Okay, so let me give you a visual. We've got a whole bunch of squares, right? Technically in the picture, they're tilted on their side. All of these squares are 5 by 5. This piece right here, okay, Eli called it the halfway thing for the first thing that came to his mind, lack of a better terms there, right? Okay, where is that in this square? Yeah, I would call it the diagonal. Okay, I would call it the diagonal because it's going right through the middle from corner to corner. So this right here is that piece right there. Okay, so keep in mind, a square has right angles. I call it a diagonal. Clayton already threw the word out hypotenuse because what is this square made up of? 2 triangles. Specifically 2 triangles that are right triangles. So yes, we can use the a squared plus b squared equals c squared. What is that called? There we go, Pythagorean theorem. You guys know math, see? I haven't taught this stuff in a long time, but it's all coming back to you. Okay, A, B, and C, what do I know?
Or A and B are 5.
A and B are 5, because remember A and B meet at a right angle. C is what we call the hypotenuse. So 5 squared plus 5 squared equals C squared. 5 squared is 25. 25 plus 25 is 50. So if C squared is 50, then we're going to take the square root, and C is the square root of 50. Not a perfect square. However, before we proceed, can you recognize anything about the square root of 50? Ooh, does it have a perfect square within that? I told you guys have your blue papers and calculators out by your side, right? I don't necessarily need my blue paper and calculator for this one. This one is an obvious one to me. I'm not saying it is necessarily to you. To some of you it is. So what do we know about 50? 50 is 25 times 2. And we know the square root of 25 is 5. The 2 stays under the radical. So square root of 50 is 5 square root of 2. So we know this value right here, which is C, is 5 square root of 2. So that means I know this piece right here is 5 square root of 2. That you can't see what I wrote. There we go. I don't have the actual stained glass window in front of me, so no, I can't use a tape measure.
Drawn perfectly to scale.
Okay. So what else can you tell me here? All I've written in right now is that this piece right here is 5 square root of 2. Across the top? 5 square root of 2, 5 square root of 2. So that means, what is the length of this window? 15 square root of 2? Because what's 5 square root of 2 plus 5 square root of 2 plus 5 square root of 2? 15 square root of 2. Okay? I also would say that I need to know the width of my window. What's the width of my window? 2 5 square roots of 2. I can't say that. He said it nicely. I can't. Okay. The idea that there is a 5 square root of 2, a 5 square root of 2. And 5 square root of 2 plus 5 square root of 2 is 10 square root of 2. Okay. We're getting there, guys. So, perimeter. What would you like to do with perimeter?
Whatever you want to do. Just double up.
Okay. Officially, this is a rectangle officially, isn't it? I tend to think 2 length plus 2 width is what my brain thinks. Okay. Clayton said double up. Okay. The other way, if you prefer, I don't care how you guys think about it, it's length plus width, isn't it? I don't care how you work it out. We're all going to end up at the same answer if done correctly. So, do some math and get an answer prepared for me. Two times 15 square root of 2 plus 2 times 10 square root of 2. Or 15 square root of 2 plus 15 square root of 2 plus 10 square root of 2 plus 10 square root of 2 is going to work out to be 50 square root of 2. Now, in this case, we're talking about the perimeter of a window. Could you convert that to a decimal? Or let me ask that differently. Could you, with the help of your calculator, convert that to a decimal? Yes. 50 square root of 2 is approximately what, according to our trusty little sidekicks? 70.7 inches. If you think about it, square root of 2 is approximately 1.414 is what I know. So you're almost doing 1.5, not quite. Because if we did 50 times 1.5, we would be at 75. Okay, guys. So a little bit of application there, using our square roots. Safe to move on?
Wouldn't it have just been easier to multiply it by 10 such a number of sides that are there? Wouldn't that have been more efficient?
You could have.
Okay.
There's a whole bunch of different ways we could have done this, you know. I'm just trying to make sure we all get to the same place. But so Ethan's saying there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 diagonals that are up there. So if one diagonal was 5 square root of 2, then 10 of them is 50 square root of 2. I'm not going to argue. Lots of different ways. I sometimes take the long way just to make sure I don't lose anybody in the process. So in the process, I kill some of you that I take the long way, but sorry. Sorry, not sorry. How's that? Okay. Moving on, example 3. Let's get back to adding and subtracting radicals. Square root of 12 plus square root of 75 minus square root of 3.
We're overthinking this. I don't think we can do it.
You simplify.
Radically good.
Yeah, but don't you simplify your things? Because you take like the 12. It's 4 and 3, and then it's 1 and 5 and 3. Wouldn't you just do that?
Okay, so good news, bad news. When we get to this type of problem on the chapter test or even on the quiz, Unfortunately, some of you will miss this because you will look and say, oh, they're all different. I can't add and subtract them, so I'm done. Unfortunately, we have some simplifying to do. I told you the blue papers are not dead, yes? I told you to have the blue papers out today because guess what? They're important, okay? Now, it is possible that this problem is done and we can't add and subtract these if those radicals don't simplify any. It is also possible that these radicals simplify and they'll all become able to be added and subtracted. And that's more likely what it is because that's the way these problems are often designed. Okay, guys, so what do you know about 12 in relation to our blue paper? Okay. Yeah. 12 is not a perfect square, but what does 12 divide by according to our blue paper? 12 divides by 4. So I'm first going to write, if you remember me doing this the other day, 12 is 4 times 3, correct? We picked 4 because it's a perfect square. What do you know about the square root of 4? It's 2. So then that 2 is going to go outside. The 3 stays under the radical. Okay? Next. Square root of 75. Is it on my blue paper? No, it's not a perfect square. Yeah. My brain always goes to, if you've got 75 cents in your pocket, you likely have 3/4, I hope. Okay, so 75 divides by 25. Your calculator is going to tell you 75 divided by 25 is 3, right? So 25 times 3. The square root of 25 is 5. Square root of 3 stays square root of 3. What do you know about the square root of 3? Okay, it's square root of 3. It's not a perfect square. Does that have any perfect squares inside of it? No. But coincidence or not, does it match up with the rest of the problem? Yeah. Now, thoughts on a final answer then? 2 square root of 3 plus 5 square root of 3 minus square root of 3.
I think it's 7. Wait, no.
5, 6, 7, minus 1. No, that'd be 6. I don't know where I got
What'd you get for the answer? What was your answer? Because I want to know if I got my answer right.
I got it way off. I was.
Okay, guys.
What'd you get?
Here's the equivalent thought process. What would be 2x plus 5x minus x?
Oh, cheesy crackers.
If you did 2x plus 5x minus x, that would be 2x plus 5x is 7x minus x. That's an invisible 1. Invisible 1 up there. So 2x plus 5x is 7x minus 1x is 6x. So 2 radical 3 plus 5 radical 3 is 7 radical 3. Minus radical 3, well, keep in mind you're minusing 1 radical 3. So what's our final answer? 6 square root of 3. What you've always got to remember, when you have a radical of any sort, square root, cube root, whatever, with no number in front of it, that invisible coefficient is always 1. Okay, how are we? Are we okay with this now? There's lots of arguments out there, I heard, so. But I like listening to you guys argue. You guys know that.
Yeah, we were going to get down.
I like listening to you guys argue because I like listening to you guys, voice your reasoning, explain it to each other, try and prove why you are right. I'm starting to say try and prove why you are wrong. No, try and prove the other person wrong. Okay. Let's try B. Cube root of 250 plus cube root of 54 minus cube root of 16. So first of all, on your blue paper, move to the middle because we now just ventured into cube root world.
Yeah.
Okay, 250. Start scanning your column to find what does 250 divide by? The biggest thing you can start with is 216. But hopefully you recognize 250 divided by 125 is going to be 2. So, 250 is 125 times 2. I pick 125 because the cube root of 125 is 5. Where's that 5 go? Outside of the radical. So I now have 5 cube root of 2. Okay? Plus, back to your blue paper, 54.
Oh, 27.
You only have 2 choices. 54, does it divide by 27 or 8?
27.
Happens to divide by 27. Cube root of 54 is 27 times 2. What's the cube root of 27? 3 times the cube root of 2. Now, I'm not saying it's always going to work, but it often will. Notice, what number is under both of these radicals? A 2. What's likely to be under our last radical? A 2. Again, it's not always going to work like that, but if you're getting stuck on what perfect cubes we could have, look to see if it divides by 2 and see what the other number is. Now, in this case, 16 is not a difficult number to work with. You only got one choice. Does 16 divide by 8?
Yeah.
It does, and it so happens to be 8 times 2. What's the cube root of 8? 2. So 2 cube root of 2. Lots of 2's. Okay, 5 cube root of 2 plus 8 cube root of 2 minus 2 cube root of 2. Minus 2 cube root of 2. I said the wrong thing, didn't I?
You said 5 cube root of 2 plus 8 cube root of 2.
Oh, okay. I don't know. 5 cube root of 2 plus 3 cube root of 2 minus 2 cube root of 2. Whatever. What is it supposed to be? You guys aren't going to argue this time?
Yes, that's right. Yeah.
Okay.
We caught that.
They're all cube roots of 2, so 5 plus 3 is 8, minus 2 is 6. 6 cube root of 2. Okay. You're getting the idea here, yes? In everything we do going forward, you are simplifying radicals, or at least trying to simplify radicals. So always keep that in mind. Don't ever just stop and say, oh, I'm done. It can't be combined. They're not the same. Check and see if they can be made the same before we go there. Okay. Example 4. Multiplying. Now, in a sense, we've already done multiplying. However, this multiplying also involves adding, which is why you see it today and not in the last lesson. So 4 plus 2 radical 2 times 5 plus 4 radical 2. Thoughts? It's a magic word I'm looking for. Distribute or FOIL. I heard both. When you are multiplying, a binomial times a binomial. And when I say binomial times binomial, when you have two terms added or subtracted times another two terms added or subtracted, you always must think FOIL, or distribute if you prefer. So, we're going to start. First, we take the 4 and multiply it by 5. 4 times 5 is 20. Then if you're a FOIL person, you say outside, which means I do 4 times 4 radical 2. Or we're just continuing to distribute the 4, correct? What is 4 times 4 radical 2? 16 square root of 2. Because when you multiply outsides with outsides, insides with insides. Okay? So that was FOI. Or you're taking the 2 radical 2 and you're starting to distribute it. So 2 radical 2 times 5. Outside, 2 times 5. So 10. Keep the square root of 2. So 10 square root of 2. And last, 2 square root of 2 times 4 square root of 2. Two times 4 is 8. Square root of 2 times square root of 2. That's one way to look at it. So, I'm not going to write that down right now, but square root of 2 times square root of 2 could just be written as a plain old 2. Or, if you want to take the slightly longer route, nothing wrong with it, square root of 2 times square root of 2 is going to be square root of 4. If you went ahead and wrote 2, you're good. It's fine, because I'm getting ready to do that. Okay. Am I done at this point? No, you guys know better than that. I mean, our job is to simplify it and clean it up as much as we can. What are the pieces you see? 16 square root of 2 plus 10 square root of 2 is going to be 26 square root of 2. Now, for the moment, this 20 out front, it's the only whole number right now, isn't it? So the 20 out front, I'm just going to carry down. So I've got the 20, 26 square root of 2, plus, what do you know about 8 square root of 4? Yeah, square root of 4 is 2, if you didn't already write it earlier, and 8 times 2 is 16. Am I done? Can I box my answer and move on? No, because 20 and 16 are like terms. They're just constants. 20 plus 16 is 36. Still plus 26 square root of 2. Now can I box my answer and move on?
Yes.
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 Why am I not adding 36 and 26?
That would be like having 36.
Right. This would be like adding 36 plus 26x. That 26 is tied to the square root of 2. You can only add it to other things that have square root of 2. Okay. Got the idea? Let's try B. Three minus square root of 7 times 2 plus 4 square root of 5. What is it I'm doing here? FOIL or distribute. 3 times 2 is 6. 3 times what? 3 times 4 square root of 5. What is 3 times 4 square root of 5? 12 square root of 5. Continue along. I know, I have to wait for it to get to a password screen. Rectify myself here. Okay. Now what? Okay. Minus square root of 7 times 2, which is going to be minus 2 square root of 7. It's just a radical and a constant, so we just put them together. And then, lastly, minus square root of 7 times 4 square root of 5. We're multiplying. So, what has to be true to multiply? Only the indexes have to be the same. So, square root of 7 times square root of 5 is going to be square root of 35. And of course, there is a 4 out front. So, minus 4 square root of 35. Why what? Because in our multiplying rules, it's just the index has to be the same. Okay, so go back 2 days to when, or I guess it'd be last Thursday, Friday. When you multiply, as long as they're both square roots or both cube roots, we can multiply. It's like saying we can multiply x times y and get xy. Okay, so square root of 7 times square root of 5 is square root of 35. It's just adding. We wouldn't be able to add square root of 5 and square root of 7. And then it was a negative square root of 7 times 4 square root of 5. So I came up with negative 4 square root of 35. Okay. What cleans up? Nothing? Okay, 6 is a whole number. Square root of 5? 5's prime, it's not going nowhere. Square root of 7? It's prime. Square root of 35? Only thing that divide into 35 are 5 and 7. It's not going nowhere. Well, guess what, folks? This big long answer of 4 terms happens to be my answer. Okay, here's what I'm going to say. Do C. Depending on timing, we'll either check C today as a class or tomorrow as a class. But work on C for me. See if you can come up with the correct answer for C. Let me guess, you already did C?
Still working on it.
We'll place 35 and 35. You're fine. And if you're not done, you're not done. Or if you're stuck, you're stuck. I mean, you know.
Never mind. Okay.
I'm just trying to get you guys to. I'm just trying to get you guys to tread on your own.
Well, Doc said it the first time. Like Friday, Doc said.
You gotta give me like probably.
Yeah, I don't think they'll ever say it again. So I guess that leaves it to me to.
I'll write the answer up here for anyone that is wanting to check that finished it after I walked past you. There's the right answer. And at this point, I mean, I look at, you guys know, you guys are the ones that have to know how to do it for homework. So, you know. I don't have time to actually walk through that today, so we may or may not walk through it tomorrow. My plan is to finish the notes tomorrow, and then homework will be due Thursday. Okay? And maybe you'll have some work time tomorrow, so bring your iPads.
You don't even know who I am, right?
Pretty good.
You like the 5 grab?